Cool. So, without further ado, I know you all are here to hear about my rant or my blabber, but I'm more here to learn about machine learning. So, without further ado, I want to introduce you all to our speaker today. His name is Anuj Garg. You may have interacted with him for post camp session in the past. And perhaps he was one of your favorite trainers when it came to Android training last year. And I can guarantee you he's going to be your favorite trainer with machine learning as well. That being said, I would hesitate to say that Anuj is master of all and he has jack of all trades. He basically knows so many technologies, right from Android to Google Cloud to machine learning. He has vast knowledge about various products and technologies. He is currently the technical lead at Code for Cause, and he leads a team of passionate developers who create impactful solutions for social good. And before joining Code for Cause, he was DevRel engineer at Google, where he helped hundreds of developers in the organization to build better apps. So, a lot of content that you are leveraging in the Kotlin side, Anuj was one of the person who contributed to it, and he has around 7 years of work experience in the industry and has a BTech degree in computer science. Folks from Rohtak say hi to Anuj because Anuj graduated from Maharshi Dayanand University, Rohtak. And he's really passionate about technology. He loves solving real world problems. So, if you are looking for a role model or an inspiration when it comes to solution challenge, here's Anuj, who's waiting for me to take a pause and take on the screen from here. With that, I will hand it over to Anuj. For folks who joined us over Google Meet, I request you to turn on your cameras if you're comfortable. That will help Anuj make it more engaging and interesting with all of you. And for those who are tuning in via YouTube, if you have any questions, pass those questions to your GDSC lead. They will share with us in the chat section in the comment box, and then we'll take it from there. All right, over to you, Anuj.
Hello everyone. Let me just
Hello,
Hello,
sir.
sir.
hello.
Hello, sir.
Hello, sir.
Hello,
You
sir. Good evening,
Hello,
sir.
sir.
yeah, this is the energy. This is really the energy that I'm expecting. This is super. Let me just set up the project in a second and share the screen, and then we will start with a very awesome journey of machine learning today. Okay. Nikita, I'm not allowed to share my screen. Can you please give me the permission?
Sorry, Anuj, can you please come again?
I'm not allowed to share my screen. Can you please share the
Let
permission?
sure. Let me check the settings. Yes, you should be able to share now.
Okay. Yes, now I'm able to share. Okay, now awesome. Everybody should be able to see my screen now. And you can put in the chat if you're able to or not able to. Awesome. We are able to see the screen. And we want to talk about machine learning. Okay. And when we want to talk about machine learning, we should start with the thought process of what everything about machine learning, AI, and what this journey is. Okay. So we want to talk about this journey. And we will start this journey with the thought process of what is AI, what is ML, what is this ML that we want to target toward, and a few more details on this area. Okay, so AI is artificial intelligence and ML is machine learning. Okay, and when we talk about AI, we are a bit more towards saying that we want something more like human. Okay, something more like, where we can specify the term intelligence, right? So it is a bit broader topic, but within that area, very small sub piece of it is machine learning. Okay, where what we simply want to say is within this area, we want to create a model where we can have some input. Okay, we can process this input through this model and we can generate an output. Okay, as simple as that. And this output can be some kind of prediction, some kind of classification. It is something on that front. We are not specifying that thing exactly till this point. We are saying that we have an input, that input goes into a model, and we are getting an output. Okay. Now, what all the things this model can do? For that, we want to divide our learning into two parts. We can have either supervised learning, okay, or we can have unsupervised learning. Okay, so what is the difference? So with supervised learning, we want some initial data where we have y as well. Y is output, x is input. So we want to initially train our model in a sense that if we give this input, then we should have this output. Okay, so like if you're learning 2 plus 2 or 5 plus 5, so some mathematical calculation you're learning. So initially, if you have that, okay, so you said 5 plus 5 is 9, but somebody is there to tell you that 5 plus 5 is not 9, it is 10. It is supervised, right? That you have some supervision that would let you know that what you're doing is wrong. Actually, this is the right answer. But unsupervised learning would be that there is no one to tell if you are doing it right or wrong. Some problems can be done with supervised learning. Some problems would be good to solve with unsupervised learning. So where you do not have the initial why, that would be unsupervised learning. Okay. So these are different kind of learning, and for these we would be having different kind of models. Swami Pal, yes. What is the question?
Nothing, wo, that was a mistake, sorry.
Okay, okay. Nikhil, any question? Okay, cool. No question till this point. We are talking about supervised and unsupervised learning. So, what kind of problem can be there where it might be that the output is for some areas we already have the output. Okay, so let us suppose you're talking about maybe house pricing. Okay, so house pricing in a city, we might have some factors, like we might have a factor of area. So if the area grows, generally the pricing would grow. So it is pricing. And we can say in generally, there would be data like this, which would be in a different houses. Each point is representing a particular house where, when you talk about a particular area, there is a particular price. Definitely, they wouldn't be in a very straight line, because there might be a single person might be in some emergency. They are selling for cheaper, and right now we are just talking about a single perspective area. The particular flat could be on the first floor, on the third floor, on the top floor, and maybe park facing, not park facing. There can be a lot of factors which can change the pricing, but because we are just targeting toward a single feature, we are just saying that a single feature is impacting the price. Because of that, we can say that okay, so there would be some data which would be showing some like maybe a kind of a direct growth corresponding to a proportional growth corresponding to uh, area. Okay, so price is growing as the area is growing. And potentially, if we could train on this model, we could come up with a line, something like this. Okay, so this line is kind of saying that if we take a broader perspective, maybe as the area is growing, the price is growing approximately on this manner. Okay, so there is some slope, some y intersection. So based on that, we are kind of getting a line. Okay, but it cannot always be a line. We are just right now thinking that definitely it is a line. Maybe it could happen that after certain time, after a certain area, maybe house prices do not grow as smoothly as it grows for the smaller areas. Maybe for the larger areas, there comes up a discount kind of a thing, that after a certain area, the pricing doesn't go as smoothly as it was going for a smaller size. So maybe in that case, after that certain point, it becomes a curve. So all those things can happen, and your model want to learn all those things. Okay, so we initially just super simplified it to say that it is a single line, it is a straight line. Okay, but it could be a curve, it could be, maybe a wave kind of a thing. Like sometime for, initially it would grow, then it would fall, then it would grow again. So, different kind of things, different kind of perspective we could have for that area. Okay, so right now we're just talking about this particular data, and we could say that, okay, if we can have some kind of, like a line or a curve or a space that can, kind of predict things. So for that area, definitely we would be going for a supervised learning. What other thing we could be having? Maybe you want to talk about data like this. We have some points here, we have some points here, and you want to create a separation in between them. Okay, so these points belong to a single label, this point, these 2 points, these a few points belong to a separate label. So potentially you could be creating a line like this, which could be separating this data, saying that if it is on the left of this, then it is red label, and if it is on the right of it, then it is green label. So maybe, when we talk about cancer, so if cancer is, dangerous or not, so we could be saying that, okay, so if the point, if the info is corresponding to this, size and etc. is corresponding to this, it could be maybe dangerous, and these points are not dangerous. Sounds good? So we talked about, this thing is classification. Okay, this is classification. We are saying that the classification would fall in supervised learning. Okay, and we talked about this in upside. This is regression. Okay, so this is also supervised learning. But maybe if you say that you're talking about maybe suggestion or recommendation algorithm, and you say you got a few phones where this is maybe price, and this is maybe um, any other feature. So maybe how royal it is. Okay, okay, and then there are some data points like this. Okay, so different mobiles are like that, and right now we are just creating more like a cluster. Definitely in real life they wouldn't be exactly like a cluster, it would be more like continuous data, but potentially you just want to cluster them together in a few specific points. Could you say that maybe there would be kind of a cluster here, 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 there would be kind of a cluster here. Okay, right now I'm just imagining it. We definitely need an algorithm that can solve this for us, but if we don't have that algorithm, maybe we could be solving it a bit more manually. But if we have a better way to do this, what we could say that we just want to feed this data, and we want to tell like how many categories we want it to divide into, and then we want to generate the labels. Okay, like this is a particular, this is label 1, label 2, label 3, label 4, label 5, label 5. So all these are different labels. Okay, so these are just different labels, and we can say now we have created a separate uh, like this is the category 1, this is category 2, this is category 3, this is category 4. Okay, so what we are doing is we are categorizing item. Okay, so we are creating categories. Okay, we are categorizing the items. Okay, okay, so now this should fall into a unsupervised learning. Cool. So if we can understand this much, then potentially we can say that, okay, there is one important thing that we can see here. To put some data into a perspective of 2D, 3D, 4D, 5D, any such dimensions, we cannot put data which cannot be represented in a numerical manner. Okay, so like, can I say your name is an important factor? So obviously it is not exactly very uh, proper way to say it, but maybe you can, if we say that your job position, so if you are a developer or a senior developer or there can be so many job positions across the board. Okay, so in the software development there will be separate jobs, and then in like pharma there would be separate jobs. So in a lot of categories there would be a lot of jobs, but the job title, can we represent these job titles in the format of a graph? In the chat you can respond, like, can we represent the job titles in the format of a graph, or like a point in a numerical manner? How would we do that? It is kind of impossible, right? We cannot, because like a software developer, or these are just terms. You cannot put them on a graph. Okay, so they are not quantities. We cannot put them on a graph. Okay, but maybe we could be saying that maybe salary is something that we can put on a graph. We can have a scalar values to it. Okay, we can have some numerical values to it. Okay, so different aspects which can be placed on a graph can play a role. Okay, but the items for the items for which we do not have a numerical value, either we would try to create a numerical value for it. Okay, if we can create a numerical value, we would use that. But if we cannot create a numerical value, we wouldn't be able to use that parameter. And this information that we are talking right now, like for like this thought process, like what we can convert and what we cannot convert to numerical values. This is going to build up our thought process for even LLMs, okay, large language models. We will take this concept across all the items. We will talk about this in the machine learning. We will talk about this when we're talking about the deep learning, and when we are talking about LLMs. This concept would stay same. Only the things that can be converted into numerical values would be able to work with machine or computer, because the computer is not able to understand those labels. You need to convert them into numerical values so that we can work with it. This sounds comfortable for everyone, right? Like, we all are on the same page that if we need to plot a point on 2D, 3D, or any number of dimensions, we need the numerical value to work with it. And computer wouldn't be able to understand like any words or something. Computer only understand numbers. Computer would understand words. We are on the same page for this. Awesome. Yes, cool. So if we got this correct, then let's create a project. New project. GDSC, or maybe we could initially just take the pie chart, so that sorry, an account of, so that things are a bit more real, kind of the things that you can copy and work with. And for the guys who wouldn't have any installations, what you can do is you can use Colab, Google Colab. So just search Google Colab, open a link, create a new notebook. Okay, after the notebook is created, you can click on connect, and you can start writing here. What I will do is, because it is going to create a remote instance and then work with it on the Google Colab. I want it a bit more smooth, so I have installed Anaconda, and I would be working with this Jupyter Lab. It's on another screen. Let me pull this here. Okay, so right now we have an empty directory, and on the collab as well we have the empty directory. Okay, we can click on any side and we can start working on it. This connected. It is simply a Python area. You can write like say print hello and just shift enter hello, and same Same thing you could do here as well. Print hello. Okay, obviously hello is not something we are interested in, but just showing that these things are working in the same manner. We just have some cells. On the cells you can add some information, and then when you are running this Python code you will be seeing the output. Okay, this is the thought process. Same here and same on the collab. You can use collab. I will be using anaconda. Okay, awesome. Now the first thing in the prerequisite that we said that we would be using, very important library and very awesome library, is numpy. Okay, import numpy as numpy np. Okay, this is the common way to import it, and now we can start working with it. If we have an array, something like this, li 10, 20, 30, something like that, what we could say that rather we want to create an array out of it, np.array. We could write this li here, and it is going to create a numpy array for me. Okay, so a few things that potentially you would have gone through in the uh, link that we provided. Right now, it would be, if we talk about the shape of this, is equal to this. We wouldn't have too much time to, discuss all the details of it, but just something that, okay, so we would have something like shape available. We can reshape this. So we can do a lot of stuff on this numpy array. Okay, and very, very awesome thing about Python is that we have a lot of different libraries, but most of the libraries know how to talk to each other. Okay, we have scikit-learn, scikit-image, we have numpy, we have pandas, and all these libraries generally are connected in an ecosystem. Okay, so whenever we would talk about a data in a particular library, generally that data, if it is in the format of a numerical arrays, they would have a way to convert into a numpy array. And because of that, even though we wouldn't be directly working with NumPy array as specific of this particular session, but we would be seeing a uses of NumPy array a lot. Okay, because whenever we want to talk about, like images, if we talk about image, what is an image? Image contains a lot of pixels. Every pixel is RGBA. Okay, so red, green, blue. Sorry, yeah, red, green, blue, and then A is alpha. So we would have RGB values and we will have alpha channel. So we just have those 3 or 4 layers. So sometimes you will see RGB layers, sometimes you would see RGBA layers. And if it is a grayscale, then you just have this a single channel. Okay, but overall we can say that it is a 3D array. Okay, a 3-dimensional array it is. Okay, so whenever we are talking about any such data, eventually what we are leading to is we are just leading to a particular kind of a array. Okay, and we are just going to take that thought process and proceed with it, like how we have some images or some data, and we can work with it to like get some understanding out of it. Okay, so let me just delete a few of these. Okay, and say that after this numpy, we potentially might use scikit-learn to use some extra libraries, some models. Okay, different models can provide us different way of working with data, and the scikit-learn is a library that can also give us some random some basic data. Okay, we could say like uh, from scikit-learn datasets, import load digits. Okay, and now if we have digits, we can say data is equal to load digits execute. Okay, and we can also see what is the part of load digits. We can tell how many classes we want. Default would be 10 digits, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we want to return x and y separately, we could say that return x, y true. By default, it is a false, so you will see a single data. If we want to just say that, okay, I do not want to divide it into 2 parts, we just want the single data. This will contain, this like, okay, so this is the data part, these are the targets, frames, all the features, etc. Rather, we could say if we just want to see it in the format of x and y, we could say return x, y, true. And in that case, we could say simply x, comma, y. These are the two things that we want to see from here. And if we want to see now, even though it is, scikit-learn, and I ask for what is the type of this x, we can see that is, it is, numpy array. Okay. Even though we not import this here, but what we are getting from this data set from scikit-learn is this x and y, what we're generating are numpy arrays. Okay. And maybe if I just say that what is the zeroth item of this numpy array, what is the shape? So 8 by 8 data we are getting, or we could say that it's 64 items. If we want to reshape it, we could reshape it into 8 by 8. Okay. So these are the values from 0 to 50 are values we can say that we would be having. And this data, if we want to see in the format of image, we could say let's import matplotlib dot pyplot as plt plot py. Okay, and then we could say plt dot im show, and then whatever the image is equal to this image. Okay, so I know it is very blur, but what they're trying to show is zero. Okay, so it is zero, then there can be some other number, maybe what is on the 10th position. Again, it is some other item. I know this data that we are picking from this is not very good, and we might want some data that is a bit better than this. Okay, at least a better looking data. We would be pointing toward that. We will be loading other CSVs, etc. But the point is simple that we want to get the data. We want to reshape it into the way that is suitable to us to represent, and we also want to work with the data to like maybe how we can classify things, how we can work with things, those things we want to work with. Okay, so we got this data, we are loading it, we want to work with it, and if we have this data available, we have x and y available. Maybe we want a model to we want to feed this data into a model so that we can work with it. Okay, so for that, right now we can see what is the shape of this, how many total rows we have. So right now we have kind of 1700 images, and like for every image we have 64 pixels. Obviously, if we have just 64 pixels, this would not be too much, right? 64 pixels is not too much. Okay, so but obviously we would want more pixels. We would see how we can get more pixels by loading this data from somewhere else. But the initial thought process is simple, like, okay, if we have those pixels, we can just show the image to you. Now we want to train our model. Okay, we want to train our model. How we can do that? We would need some models. Definitely we could create those models from scratch up, but in most cases you should know how to create them from scratch up, but you wouldn't be doing that in the production. Okay, you'll be just loading the model, you would be tuning the hyperparameters, and then you'll be working with it. Okay, so where are the models available in the scikit-learn? You could say maybe I want to use a decision tree. Okay, so from sklearn.tree, you want to import the decision tree. Okay, so if you are saying in this decision tree classifier, you could say that I want to create a tree that is a decision tree classifier object. You could tune parameters like if you want to use Guinea index, or if what kind of criteria for dividing the points. Like if you want to say what are the trees would look like. Let me change the screen to show that. So, like whenever the data is coming in, based on the different parameters that you would have on it, different features, you would be saying that okay, if the feature is less than this or greater than this, there's some kind of a criteria. Based on that criteria, we could decide to divide data. Okay, so when we are dividing, we would use something like Guinea index. Okay, something like entropy. because we want to reduce the entropy, we want to reduce the randomness. Okay, so if we want to focus on reducing the randomness, we could say that we want to use entropy for dependence data, and Guinea is talking about the purity. Okay, so Guinea index could be saying that how much pure this data is. So overall, the thought process is same, but we could be using different mathematical calculation to work with it. Okay, so we want that after a division, after a few division, when we reach the leaf node should say something like this. Okay, so after these all these classification, we could say that now it contains only a single kind of data here, or at least most of the data is focusing toward a single type. And if we want to do this through the thought process of a tree, you could be using a decision tree. Okay, as simple as that. So you could be using a decision tree for that. So if you want to use a decision tree, you could be saying, I want a decision tree classifier. I want the splitter based on best or the square root or different kind of rules. What is the maximum depth that I want for this? What are the maximum number of features that I want to work with? Do I want to create a, so different rules that I can have for this decision tree classifier. Right now, I'm not changing any parameter, but you could be changing a lot of parameters to have a different output. You could say a different, accuracy. Okay, so we created this object. Now maybe we want to divide our data. Okay, if we want to divide our data, what we could do from Aniket is saying great explanation, bro. Yeah, thank you. Okay. If any of you are facing any trouble, definitely we'll be taking the doubts in the end as well. But in the between as well, if you face any trouble, if you feel the pace is too high or you're not able to grasp a few topics, just drop in the comments so that I can take a look at it, and maybe we can, variate our learning thought process at that point for some time. Okay. Cool. So we got our decision tree and we created the object. If we just want to send the whole data, okay, we could say something like this tree. Okay, then on this we have a fit method, and this fit method could say that okay, I want x and y. Okay, this is the x and y that we have available. X is for input, y is for output, and after fitting, we got our tree. Okay, if we wanted to divide this data first, we could be saying that okay, from scalar dot model selection import train test split. Okay, so instead of giving the whole data to the tree, what we could rather say, we could say that okay, with the help of train test split, we can divide our data. Okay, so we can use this. Okay, so we are saying that from this x and y, we are actually generating x train x test, y train y test. So test side would be 33%. So if we have 1700 kind of data, so 33% of this would become the test, and rest of them would become the the train data. Okay, so we are dividing the data x train x train y train x test y test. So now let's recreate the object so that we do not have the impact of the previous tree that we created and fitted. And now on this tree, let me fit my X train and Y train. Okay, we got this here. And after fitting, what is the next thing we want to do? We want to check the score. Okay, tree dot score. And on this, we can provide the test data. On score, we can provide the test data, and it will tell us how much accuracy we have for this data. X test and Y test. Okay, we have 84% accuracy. If we want to predict for a specific image, we could say tree dot predict. Okay, and now with this predict, we can provide maybe okay, we want on X test. Let me send the first 10 images. We are slicing to send the first 10 images. This is the prediction of our model. Okay, so the first 10 items that I'm sending, first is 6, then 9, then 3, then 7. blah 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 blah, and x, sorry, y test. This is the real data. These first 10 items are the real data. So the first item was 6, we said it was 6. Second was 9, we said 9. 3 is 3, 7 is 7. A few items might be wrong, but not all, like this. This is wrong. So some items we are not, like this prediction, we said this number is 3, but actually it goes 2. So this is something that we could create by ourselves by using a decision tree. Okay. Okay. Yeah. Good question. What is the benefit of this random state? So random state is kind of fixing how we are going to divide the data. Okay. So when we're talking about randomness, randomness can also be controlled. Okay. So we are kind of adding a token to the randomness, which is kind of fixing the randomness. So if I run this, split again and again, because we have specified a random state. So for random state 42, it would always give the same answer. For random state 33, so if we are setting the random state, we are kind of setting up the randomness as well. So running this 10 times or 100 times is not going to change how we split the data. So when we are running it the first time, if a particular item is going into extreme, it would always go into extreme. If a particular row was going into x test, then it would always go into the x test. Kush, now are you able to understand that? What is this random state? Okay, so it is kind of key to the randomness. So if you fix the random state, you are fixing what the output would be. So not exactly the complete output, but you are fixing the randomness. Okay, so if you do not provide this, then it would be picking up a random state all the time, and then you would be having kind of a different data all the times. Okay, so generally, but why you would try to fix a random state, that if you just change a few other hyperparameters and then you check the accuracy, it might happen that, yeah, exactly. So it might happen that we do not change anything, but just because in the next time we got lucky and we had better split of data, we might have better and better or worse accuracy, and we might feel that the other changes that we made are actually creating this accuracy. But actually, what is changing that accuracy? Just different data. Do we really want to do that? No. We want to observe the impact of other things, not how we are splitting the data, right? So that split of data potentially should be remaining same so that we can see the impact of other parameters that are changing. Okay, so that is the focus. That is something that we want to work with. Okay, cool. So if we got this, if we could understand this, this is kind of giving us a good vibe of how things should work. But as a developer, just seeing these number change is not something I'm interested in. Okay, I want to create a tool that potentially can take the input from the customer, can work with it, and can give some output, right? And for that, the second thing that we talked about, sk this Streamlit would be a very awesome tool to use for that. Okay, we are going to use the Streamlit because it is going to help us create very awesome tools with a least amount of effort, and we will see how. Okay, so let me open this, create a new project, GDSC workshop, ML. Okay, and here I'm starting my code. Okay, in Python we know, like, if we want some dependencies, etc., what is the name of the file we create for that? What is the name of the file where we keep the dependencies? Requirement.txt, yes or no? Okay, requirement.txt. Okay, we will be adding the comments there as we need them more and more. And for right now, we could say, okay, I want to use Streamlit. So from, not here, not in this, in main. from, maybe just import Streamlit SSD. Okay, and now we are going to create a very awesome small page saying that, okay, I want to add a header on my page saying this is my ML page or ML demo, something like this, and I just want to now trigger this as a web page. So Streamlit, Streamlit, run main PY, and let me bring this page here. This is my demo. I can come here on my Python page, can come and change some things like st dot input. Okay, let me save this, refresh here. Okay, this text input would need the label. Enter your text here or whatever the label you want to add that. Come and refresh. We got our input box. See, this is so cool, isn't it? We want a button, st dot button, submit. Right? So we want to upload an image. So we can, create an uploader. As simple as that. We can come here. Sorry, uploader will need some extra parameters. Let's see what other parameters would be. A label is mandatory, okay? All others are optional. Upload image. A very nice UI for uploader, isn't it? We can browse file, we can select image, etc., whatever we want to do, and that would be working. Right? So, but very important thing to understand that this is not creating a very production grade product. Okay, for very small things it can be considered production grade for very small areas that you want to work with, but I wouldn't be saying that if you have a complete separate application, the whole thing you would be working with Streamlit. Okay, so it's more of very data science heavy or very machine learning heavy kind of things you would be demoing or working in the format of Streamlit. But for those small areas where just want to upload image, do some changes, do with work with all these small stuffs, it is very awesome tool to work with. Whatever the ML model that you are working with, if you have some text, for that you want to show some output, you want to upload image, you want to work with anything, it is going to help a lot. Okay, and we are going to use this to say that, okay, we have a model that can load images and we should be able to tell if it is one or two or whatever. So should we have a way to draw on the canvas and then we should be able to see that image if it is one or two or whatever, we should be able to predict from our backend? That would be cool, right? Yes or no, everyone? So if we can have a canvas here, that would be cool. So we want to add our canvas here. So let's add our canvas. Streamlit, canvas. Okay. So with the help of pip, we can install it. Otherwise, we could just add it into our requirements. Okay. And because it is requirement, so Streamlit, we should add Streamlit as well here, and Streamlit drawable canvas as well here. So when these two things are added here, if at any platform, whenever these are required, this requirement would be picked up, and we would be able to work with that. Right now, we want to use this file uploader. So from input, let's see what they want us to work with SD canvas. Okay, and instead of all this, we want to use our SD canvas. SD canvas, and now we have a few parameters that we can work with. If we want a fill color by default to be white, we could say white or whatever the color. The very common thing that I want to work with right now is saying that I just want, because most of my images were square. So right now I also want this to be square. So I'm saying that height is 400 and width is 400, something like this. Okay, I can change how the brush size would work and all that. And when I come here and refresh, I'm seeing my canvas. Okay, I'm doing true or whatever. I can have undo redos options. Okay, we can delete, we can draw some items. So this is a very basic canvas. If you want to change color, we could do that. If we want to change the stroke size, we can do that. Stroke width is maybe just 5. It would be very thin. Refresh and you will have a very thin width of your stroke. And maybe you could be saying 50. It would be quite thick. Cool, right? Right? So with the help of this, we are able to create a canvas. Okay, but you would say that this is just a canvas object. What if I want to grab out of what it is creating? Okay, it is creating some image, right? And I want this image available to me. Okay, so if I say output or yeah, canvas output, canvas output is equal to st canvas, and now we could say if canvas output dot image data is not null. Okay, or we could say just the image that exists on this. Then I want to check what is the type of this. Okay, so we want to check, let us suppose, what is the type of this data. Sounds good, right? Let me refresh this. Two. 1 second. Canvas output. Okay, so we should say and canvas image print type of. Okay, so what we can see is we have the ND arrays available here. So whenever we are working with this, we are seeing this n dimensional arrays. Isn't this something that we expected as well? that when we are working with this, when we are talking about images, we would get ND arrays. And if we want to check the shape of those ND arrays, what we should get? 400 by 400, yes or no? And then maybe because of RGBs, we can have, 3 or 4 channels. Okay. So if we say that we want to print the shape, refresh, something like this. Okay. Sorry, not type, we want shape, the real shape. Okay. So we got 400 by 400, and then we got shape. Okay. The channel length is 4. Okay. Probably asking, sir, is possible to change Streamlit default web page UI? In a broader sense, yes, but not. So what you can add is you can add a little bit of HTML and CSS. Okay, so you can add HTML, CSS, because of that you can change. But when you're configuring everything, you potentially might not be taking the full advantage of Streamlit. Does that make sense, Prabhu? So if you want to change like theme color or some small things, you can do that with the help of CSS. But if you're changing a lot of things, then you're not taking the advantage of Streamlit. So I'm not saying that web development can be totally replaced with Streamlit when you're talking about ML. Okay, it's just easiest way to start with things. Later, so you can say kind of all POCs, proof of concepts, you can like create the individual thing that the models that you're creating and deploying and creating a POC. Definitely, you can do that with the help of Streamlit. Later, you can keep your Python to your backend. The front end you can create with the help of React, Angular, whatever you want. Take the input, send it to the server, process, return back the values. Okay. So, but Streamlit is not specifically for creating the production grade file application, more for POCs. Okay, or as a student, you can have a lot of you can say concept projects working with Streamlit. Okay, cool, awesome. So we got this. We got our canvas. This is the canvas. We want to display our image. Okay, so if we have the image available, we can show this, or we can show that image. So if image is available, could I say sd.image? I want to show the image. Let me just create this copy here so that we don't have to rewrite every time this image. Okay. So with the help of this, can we say whenever I'm updating this, okay, this should get updated. If I'm changing this, deleting this should get deleted. Drawing this is getting created. Crazy, right? With very, very small effort, we can create a copy of this here. Okay, because this ST image can take a lot of things, and one of that is numpy. Okay, so we can get the numpy array, we can use the numpy array here, and we have the numpy array here, so we can simply work with it. But I do not want this size of the numpy array here. I want maybe something smaller. Initially I had only 20, like 8 by 8. Maybe the standard size of MNIST data is 28 by 28 image. Okay, and we will because it is grayscale, we will only have one channel. So maybe I want to work with that. So I want to reduce its size to, instead of 400 by 400, I cannot ask somebody to draw 28 by 28 image. It would be very harsh for them, right? A very, very small image they would need to work and draw on. Okay, so they will draw on a high scale resolution, but I want to low scale it and then utilize it on my prediction model. Okay, maybe because that would help with the training, etc. part. So obviously, if we had a large scale image data set, we could feed on the data set, feed on the model, and we could train our model like that. But for MNIST data, we would have the 28 by 28 images on which we will train our model. So for the prediction part as well, we will need to downscale it, the original image, right? For the output that we have. So for that, we can use other libraries. So we could say that from maybe sk image dot color, we can import RGBA to RGB, and we can import RGB to gray. Cool. Obviously, right now you wouldn't be seeing too much of difference here, because you will say that, oh, this is white, this is black, fine. Okay, isn't it already grayscale? But because we are creating this RGB because with the help of 4 channels, and I do not have 4 channels when I'm talking about my inputs. Okay, I don't have the RGBA values for individual pixel. So I want to reduce that. Okay, so to reduce that from RGBA to gray, could I say that, or right now maybe say that it is RGBA image. Okay, from this RGBA image, let us suppose I want to convert and create RGB image. So I could say RGBA image to RGB. I'm passing this image. Okay, and then I want to create a grayscale. So we could say gray image is equal to RGB to gray. We could pass on this image, RGB image, and maybe we want to reduce the size as well. So we could say from sk image dot transform import resize. So small is equal to resize which image? Gray image. To what size? 28 by 28. Okay, and now I want to draw this small image. Okay, so st.image small. Cool. So just with a few steps. So in a production setup, I don't really want to draw it. That's not my requirement. I'm just doing it for the sake of showing how it would work. Okay, so with this, I could simply say, come back here. Now when I'm working with this, I'm seeing this data. So with this is the output I'm creating. Okay, if I'm saying it is actually 2, this is the 2. 3, this is the 3. But in my MS data, actually I have the reverse data. The background should be black and this data should be white. So could I say, because the minimum and maximum value, minimum is 0, maximum is 1, if I revert it, I will say 1 minus small, and then I come back here. Doesn't it look like what we expect? 28 by 28 image, and now this is 3. Looks and sounds good, right? Why 1 minus small worked? Okay, so if we say the grayscale value, the minimum value is 0 and the maximum value is 1. So if 1 is white and 0 is black, and I say 1 minus original, 1 minus original value, so it would broadcast and reverse all the values. Okay, so whatever is 1 will become 0, whatever is 0 will become 1. If it is 0.7, what is 1 minus 0.7? 0.3, and if it is 0.3, then it will become 0.7. So because the original values are 0 to 1, it is just reversing on that. Sounds good? Okay, so the only thing that we would need to make it work is that if we already have a model, we can pickle it to store the serialized version of it, and then we can use that serialized version to generate a prediction, and we can print that prediction here. Okay, so we could say that we want to add a text, st.text, we could generate the text, and that we would be adding here. Okay, and that would be our homework, so that we can move to the deep learning part. Okay, sounds good to everyone? Yes or no? We have the model, we can pickle from that file, we can load on this file, and then with the help of that model, we can predict. Only thing we will need to change on that model file would be that instead of using 8 by 8, we can use any specific MNIST data. We can say MNIST data download. Maybe from here you can download a better data, and then you will have a better model to work with. So some use .pkl, some use .h5. So h5 are different items. So .pkl is for pickle files. .h5 are for different models. Okay, so now we are going to start with deep learning, and when I'm talking about deep learning, I can talk more about h5, what it is, what kind of model we would be storing with either .tf or with the .h5. Okay, Prabal, make sense? Okay, cool. So now the next exciting thing. We understood a few fundamental models. Now we want to jump deeper and we want to say, isn't it too crazy to differentiate about different models and how we want to, work with things? Maybe we just want to provide something more of a, human brain kind of a thing where we could say, okay, so instead of neurons, we would have some artificial neurons that should connect and should transmit data. And now they should balance their weights and something, some correction in between, so that we are getting better output. Okay. How things would happen in that sense? Let's open TF Playground. Okay. So it is a neural network playground. We can say, let us suppose we have two inputs and just one neuron, reduce the layer and pick up this data. So if we have a feature corresponding to horizontal, we have a feature corresponding to vertical, we have a neuron who should create kind of distinction. So like what should go left, what should go right, something like this. So can it divide this data? Okay, let's see. It can. Because of the single neuron, it would create kind of a segregation. So it would say that whatever is on the left of this line is this category, and whatever is on the right is this category. What if we have something a bit more sophisticated, like this? Now, can a single neuron differentiate here? It cannot. Okay, so a single neuron would not be able to divide the data in a manner where it would be able to divide this data and this divide. So this is orange, this is blue, this is blue. It's now difficult for a single neuron. What I simply need to do, add a few neurons, run it, and now it's able to do that. Do we need to change any of our way of learning things or any of the models? No. So this is the power of deep neural network, that if we just increase the layers and increase the neurons, it without changing the strategy, it helps us create model where we would be able to adapt to the new data. Okay, definitely we will still need to, as we see more sophisticated data, we will still need to optimize things, but it is better than the previous version, isn't it? Okay, maybe we have something like this. So if we have a few extra layers and every layer got a few extra neurons, and now we should be able to do something like this. Obviously, we wouldn't need these many. These many should be sufficient. It is going to just take a bit time to divide things. We might need to change a few properties, or we can just increase a few neurons if we don't want to work with that. And it should be good to go with this. Okay, so this is the outer data, this is the inner data. We are able to classify this. Cool, right? And right now we're just talking about classification, but we could be saying that we want regression data or whatever. So for that, we want to create our model. Okay, and I'm going to use TensorFlow to do that. Okay, cool. Let's say we got back Anaconda open, launched lab, opening lab here, and pick the lab here. new file. What we could say, we need the data. So from TensorFlow dot keras dot datasets. Let's actually from TensorFlow dot keras dot datasets import MNIST data. Okay, and we want to get the data out. So on the MNIST we have dot load, and here we can say that it would be producing X train, Y train, X test, Y test. Okay, now we want to create our model, deep learning model. So on the models, we want to import a sequential model, and on the layers, maybe I want to have a input layer that would be talking about what the input size, etc. would be. Then maybe we want to talk about uh, how, if it is 28 by 28, we want to flatten it so that it becomes 784. Then we can have a few dense layers. So these are the dense layer that we already saw here. Okay, these neurons. Okay, and every neuron would have some activation type. Okay, and what is that activation type? We wouldn't have too much time to go in very depth of it, but in a broader perspective, we will talk about it. Okay, so if you want to create a model, simply say model is equal to this sequential model. After this sequential model is created, I can add items into this model. Okay, add layers. We could say that we want a input layer. So if we have an input layer, then it would have some shape. We got a shape of 28 by 28. Okay, then I want to flatten it. So add flatten, so that it is now, instead of 28 by 28, it is 784. Model dot add dense layers. Okay, we are saying that it has 784 features, so we want to reduce the features. 784 to, let us suppose, 200, and from 200, so maybe let's add activation ReLU here. So there exists a different type of activations which will say that a particular neuron, if a particular threshold is passed, it is, either on or off. So this activation is talking about what is the output that is going to come out of it. So we can say different activation function exist. So tan inverse would be talking about the tan inverse graph. If we say input is this value, then tan inverse would be showing what is the tan inverse value of that particular input. ReLU is, 0 for negatives. For positive, it is same as the input, and then leaky ReLU would be taking some output on the negatives, complete on the positives. Then there is sigmoid. So there exist a different items that you can work with in the format of activations. So whatever those function mean mathematically, whenever the neuron is getting some values and it is calculating on that, if the output, if the value, so the values goes with the activation and then we get the output. So if it is ReLU, for negative values it would be 0, for positive value the same. So just a mathematical thought process. So you can take a look at different activation function on that point. Okay, so we can just copy paste this a few times. We just want to reduce it to 10 classifications that we have. So we have this 200, then we got maybe 100, maybe then 50, and then finally 10. Okay. On the last one, what we want is that only a single item should be going up, and the value potentially is corresponding to the, just 0 1 kind of a thing. ReLU is not talking about 0 and 1. Okay, so because of that, I could be using some like sigmoid here. Okay, so the focus is not about these terms. I'm just saying that, okay, so we can create a model where we have different layers. Add, we forgot to close some brackets. Okay, and now we could say model.summary Okay, and this is the summary of the model that we already have here. Okay, now if we have this data, how we could train our model? We could say we will need to compile our model, model.compile. Okay, we will need to tell optimizer we can potentially take add. Okay, there isn't enough time to discuss what different optimizers are. We can say optimizer, the we cannot talk about different optimizer, but we can simply still discuss uh, like what should be the optimizer, what should be thought process of optimizer. Like when we are saying that there is a forward for saying that uh, when this is the input, potentially this should be the output. Okay, so when we're saying that this should potentially be the output, there should be a way of differentiating. Okay, this is the expected output, this is the real output that we got from the prediction. There is a change. How this change should affect the weights and biases of all my neurons. Okay, so that is the thought process of my optimizer. Okay, so Adam is kind of a combination of two different optimizers, and this is pretty common to use Adam on a lot of things. So but it is kind of a homework on your end to take a look at different optimizers that would work great. Okay, so right now we are just taking a look at what the power of deep learning is. Okay, so we can say that optimizer is Adam. We can say that how we are going to generate loss. Okay, so if we cannot tell what the loss is, can we reduce the loss? Is it, is it possible to reduce the loss when we don't know what the loss is? That's not possible, right? So we would need to know about the loss. Okay, so loss, because we are talking about the categorization here, we will need cross entropy. So from here, red losses, import categorical cross entropy. Okay, but I don't want to create the object, so what I can simply say is I want to use the default object for categorical cross entropy, and then for matrices I will talk about accuracy. Okay, as simple as this. So after compiling the model, now what I can do, I can push my data in. Okay, but before pushing my data in, can I see that when I talk about my y train, this y train is for every input, there is a single value output. But in our model, what is the shape of the final vector? This is the size of 10. Why? Can we say that if the output is 5 and output is 6, the difference is very minor, or is it totally a different digit? If the value was 5 and you said it is 6, should you say that it's a little bit different? No, it is totally different. So if you're just putting up a single point out, then you would be saying that, okay, so I want this to optimize to be as close as to the real value possible. But in that case, instead of 5, I'm showing 5.5. I wouldn't say it is totally wrong. I would say it is slightly wrong. So instead of one output showing the exact value because it is categorical, I have created 10 out. Okay, and each would be having either value 0 or 1 or something in between. And I'm considering those are kind of possibilities, okay, or probabilities that I want to work with. Okay, so I do not want those values to be 0 or I do not want those values to be a single value 0 to 10, 0 to 9. I want those values to be independently 0 to 1, and the maximum value would be telling that this is the highest probability of this item to be being maybe 5, maybe 6, or something like that. Okay, so that's the focus we want here. For that, we need to convert this y train into y train hot notation, and for that, we have a tool, a utility to categorical. Okay, so from TensorFlow dot keras dot utils import to categorical, import to categorical y train hot is equal to categorical y train, and number of classes are 10. Okay, so if we take a shape of this, now we would have 10 columns. Okay, and for this, now if I want to fit on this model, I can do that now. Model dot fit x train y train hot, maybe batch size if you want to provide 10,000 or something like that. Okay, and then epochs, maybe 10 epochs like this, and I run this. Okay, I'm seeing a few accuracy gains here, and finally my accuracy is something like 89%. Sounds good? So now if I see this, if I got my model and this model now want to predict, okay, this model want to predict what is the maximum, what is the value right now for X test first 10 items. Okay, obviously we will be seeing this value in the y hot notation manner, and we don't want y hot notation. What we want is the real values. So we can say uh, corresponding to each, or maybe if you just want to see a single item, yeah, block from 0 to 1. Okay, so can you see this is the highest value here? This is power minus 1, power 13, and here this and this. So a few values nearby, but overall the values, other values are down. These other values are not too much. If I want to say what is corresponding to each column, what is the maximum value, based on that we should be able to figure out. So some numpy operations we can do here to figure out what is the maximum value. Okay, simply say dot max index and we can get the value out. Okay, but the thought process is simple, like we would be able to get the output here, maybe 1 output, 10 output, 100 output, and we would be able to correlate the values. So this is the thought process of deep learning. Okay, but our focus is now large language models. What are the large language models? They are actually the deep learning models with a few different tools that we can utilize. After that, it is simply thought process of we got a sentence. From that sentence, so I said in the very beginning that we cannot have like words etc. work with us in a manner where we can produce some output. Okay, we want to predict in a mathematical term, but this is not going to help us in a mathematical term. If you have a sentence like I want a smartphone of I want a smartphone for a teenager. So is it a numerical? No, it is not. How we can convert it into numerical? We can use something like word embedding. Okay, so word embedding, let me show here. What is the thought process of word embedding? Word embedding is saying, sorry, that if we got some data, we got some sentence. If it was like if it was in the format of a color, if we say something like is red, green, or blue, could we put that point in a RGB plane? Yes or no? In three-dimensional plane, we could put any of the color. This is red, this is green, this is blue. We could put that very comfortably. So if we got 400 or 500 dimensional plane, could we say that now on that much of dimensions, we can put all the words or all the contexts on that plane? And if I'm seeing a new word or new sentences, now can I relate those to older sentences? Okay, so if I'm asking that I want a phone for teenager, or if I'm saying that I want a low spec phone with higher configuration, with high capacity of working with social media and gaming, or I can change the sentence a little bit, but overall context would be very similar. So on those 500 dimensional plane, that would still represent some nearby points, even with different words that I can refer to. Yes or no? Everyone? You're reaching the same point, right? So this is the thought process. So you would hear this LLM and vector graphs a lot, vector databases. So what are the vector databases? Vector databases are the databases which are comfortable in storing and searching those vectors that we will be creating with the help of embeddings. Okay, so if we can store and work with those databases, to store the vectors and search the vectors. So if I'm talking about a specific thing, and then I want to know what I have in my database corresponding to this thing. How can I search that? Based on those vectors? After I search it, we want to feed it into some context, feed it into an area which can generate the text for us. Okay, so that area would be LLM. Okay, and all of you would have heard about Gemini, right? So let's jump to Google Cloud, Google Cloud platform. Not on this account. Let's here open here Google Cloud. We will open the console. Okay, let me select the GDSC project, and here we can say we got our Vertex AI. Okay, so this Vertex AI is one-step solution for creating the models, kind of the models that we created initially. So we can create the deep learning models here, or we can create the classical models here, and we can also use auto model. So auto model is a feature by Google Cloud where you do not have to tell which model to choose for the output. You just say that this is my input, this is the output, and now it is the responsibility of Google Cloud how it choose that best model which will be giving us the best accuracies and managing all the hyperparameters by itself. Okay, so if you do not have a very customized kind of a data which potentially need a lot of cleaning, etc., you could be directly just using AutoML by Google, and it is like awesome thing. Okay, so but if you don't want to use AutoML, you can write your models here, custom models you can write here. And additionally, if you take a look at the different features here, like if we talk about corresponding to talk, like speech, we want to talk about images, all those items are available here as well. Okay, so in the model registry. So if first let me I should discuss about this. Uh, so you will have your data. Okay, so then you use that data and clean it to create a better data. Then you feed this data into model to train the model. Okay, then you expose that model. Okay, deploy the model. So somebody can use it on the help points. Can you see all that here? Here, create or manage data sets here. Let me enable the API. Okay, so you can create and manage your data sets here. You can train them here because you will have the data set You can create a new model, train new model. You can provide all the information that you want. Do you want to use AutoML? Do you want to create a custom training, etc.? You can do all that here. Okay, you can set hyperparameters after setting up all the other things, and after that you will right now our model registry would be empty because we haven't created any model. But after if we have our data sets and we create the model, we would be able to see those models in the model registry. And if we have the model, we have them in the model registry, we would be able to create the HTTP endpoints out of that. That would be cool, right? So that our any of the tool could be making the API call to that endpoint, and we could be utilizing that data. Okay, that sounds good. And if we wanted to do that to something like LLM kind of thing that potentially should be available to us, how could we do that? So Gemini Pro API. So we should be able to make a API call to Gemini Pro. I think this is get API key. So what we need to do is we will need to provide the region that we have. We will need to provide the project ID region again here, and then we can make the API call. And the request body we can provide what are the different things that we want to send on our API call, and then we can have the output for that. Okay, so let me see if I already have the example for that, because we do not have the time to create a custom example. I should have from send. ML lab. Here I have this example. Yes. So how you can connect with Gemini API very, very comfortably? You could be just let me remove this. You can make an API request to the URL. So same way you make any API request in case of Python, you use a library like requests. You got the API endpoint available. Okay, this is for your LLM model. And so obviously in this, your region would change here, your project ID, all that would change here. With the help of Google Cloud CLI, you will be able to create a token. So authorization bearer token, and you can find your token. Then on the data, you can find your prompt. Something like this, whatever the prompt you want to say. So if you are loading a request, you got this, then you say that write a poem about Google Developer Student Club. And this is the number of tokens. So if you reduce this, the output would be smaller in the size. If you increase this, output can be potentially can be greater in the size. You can make a request, and then this is the output. Credential got expired. We might need to rerun my. Let me just create G cloud create token, G cloud auth print access token. I can replace my access token here. Okay, now we can see the prediction here. On the predictions, we want the 0th item, and on that, we want to see the content. This is the poem. I can print it in a prettified manner. Okay, in the realm of knowledge, where the minds ignite, a beacon of learning shines so bright. Google Developer Student Club, heaven of code, where dreams like flight and ideas explode. Okay, API key I am getting from a Google Cloud account. So definitely you will need to have a Google Cloud account. If you have any debit card or credit card, you can create a trial account. You will get 300, something like that, 300 kind of USDs for the trial. And for that, you can just turn on your Vertex API keys, and so key would be cloud specific. You're just adding the permissions when you open the cloud and open this area. Um, so on the top, if you open Vertex AI, if you start with anything, they will say, do you want to enable this? Do you want to enable that? So whenever you want to use any specific API, you will be just enabling them. And because of that, your token, if I let me just even show this here. This is the command. If you have the Google Cloud CLI enabled, then you will be able to run G Cloud auth and print access token, and it would be printing your access token. Awesome. Cool. So that's all for right now. And we discussed how you can create a basic, SQL model, how you can import data, what you can do with Streamlit, and finally we saw a few things on your Vertex AI platform. So that was all for today, and I hope you guys really loved the session. And if you guys have any doubt, we can take those doubts now. Any questions from anyone? Okay. Bypass accuracy inside the list. Can we pass multiple matrices? Yes, we can pass multiple matrices. Accuracy is just something that we wanted to see at that point. But there might be some models where accuracy might not mean anything. When we're talking about categorization of items, where we are just creating the labels, is accuracy even a parameter that you want to check? Can accuracy be something in that case? No. So in that case, there is no accuracy that is to be checked, or the matrices that you want to even show. Double core. Yes or no? We can show losses. We can show anything that makes sense corresponding to that particular model. We can provide those matrices here. That okay. So we want to see these matrices and we want to work with it. Another question? The value inside dense, those are the number of neurons. Yes, exactly. Okay, not pixels, neurons. So, but And the thing is that every pixel was working as a value. So when we're creating an initial input, we are saying that why we were calling it 784 because 784 would be the inputs. Okay, so as we reduce the number of neurons, we are condensing the values, the condensing the features that we are making them more sophisticated features. So because of that, we said, okay, we do not want to say from the 74 inputs, we just want to reach to 10 values. We could do that, just saying that we just want a single layer, but then we wouldn't be creating a deep neural network. So when there are some, hidden layers, then you call it a deep neural network. Okay. So those layers are actually creating more sophisticated patterns. So if we see here, TF playground, with just a single layer, even if we increase a lot of neurons, okay, they wouldn't be able to create a lot of sophisticated outputs. Okay, so we could create this much, but can we create this much? So now, for just a single layer, creating a pattern like this is not possible. So you will need extra layers so that they can create much more sophisticated patterns. Okay, gradually it will tend to reduce the loss here. It is now able to create more sophisticated patterns. You can see here. Something easier to brief on deep neural networks for beginners. Yes. So let me just drop my so one thing that you guys can start with is you guys can on TensorFlow playground. You can start with a just seeing what these things are. Okay, and there is one awesome course by Deep Neural Network by OpenCourseWare. This can also help you guys a lot. Okay, and if you guys want to interact with me to have a session in your college, maybe we can have directly reach out. uh, we can work together on this. You can let me drop my LinkedIn here. If you want to reach out to me, you can reach out to me. I can even maybe we can club up a few colleges and we can also do a dedicated session to help you guys work better with that. Okay, so if that works for you guys. So definitely for every college individually it might not be possible, but if it is a virtual event, potentially it would be possible to club a few colleges to have a better understanding on these topics. Okay, any other question? The more neurons and layers always produce more accurate and sophisticated outputs. It's not like that. Sometimes increasing the number of layers can also become bad. So kind of hyperparameters, in the same thought process of hyperparameters, you just play a little bit to check how things would work out. Okay, so sometime with the help of deep neural network as well, you can do overfitting. Okay, so because less number of neurons, less number of layers wouldn't be capable of overfitting, but more number of neurons and more layers can do overfitting because they are able to fit better. And if they are able to fit better, they can do overfitting. So those kind of situations can be there when you are increasing the number of layers and increasing the number of neurons. Additionally, as the layers are increasing and the neurons are increasing, you're also increasing the computation. So for every input till the output, how much computation you need to do for that output to produce. That's something you're increasing, isn't it? So cost for every prediction is increasing. as you are increasing the number of neurons and increasing the number of layers. Uh, Sanitya, what I would suggest is that just clear up a few mathematics principle that you would need for that probability and a few of matrices concepts, and then you can maybe so it's not very specific thing like how much, how many hours for how many months. Those things are generally quite vague. But I generally suggest that whatever you're learning, okay, irrespective of how much time it will take to complete everything, you should just have a fixed time every week or every day. Okay, maybe you can start with maybe 4 or 5 hours a week. Okay, and you can just proceed with things. So with the consistency, you will have better chance of learning things in a shorter span. Okay, so but there is no complete guidance of like, okay, maybe in 3 months it can be done complete end to end, or maybe in 2 months. For some people it could be just 2 months to complete everything by just putting 4 or 5 hours a week. For some people, it might be a bit more. Okay, but don't worry about it. Just be persistent. Dedicate whatever the time you can per day or per week, and just stick to it. That's all I would say. Too much content. Generally, what people do is that they pick up a single model or few models and they just try to go deep in it. For a very beginner, I don't suggest that. I just suggest to explore, go wide and broad, and then from that perspective, you just take a first walkthrough of the whole machine learning and deep learning, and then you come back again and then you dive deeper. Okay, there's so many things. It's not even done for me yet. After working on it, for multiple years, so it is not going to be done ever. But you just keep on exploring more. Okay, but just complete end to end one time at least. Uh, More or less, yes, Amo, yes. So it's kind of trial and error. So obviously, a few things with experience, you understand what kind of things are going to make things better or worse. But you cannot always say for the surety that if it would be the best model. Okay, so this with the same concepts that we already have, people just keep on changing the layers, and with different obviously there comes different philosophies as well. But with the different philosophy, different research, we combine and create different models that increase the accuracy. So there is no single set of rules which will just increase the accuracy. You know, as we proceed further, and as more research is happening on this, there are coming different rules, different kind of suggestions that tell how you can increase the accuracy of things. It is not totally trial and error, but it's not totally just fixed set of rules that already exist. Okay, awesome. So I think that's uh, kind of done for me. I do not right now have a lot of time available, but definitely you can reach out on the LinkedIn that I gave to you guys, and maybe we can, later we can have extra session to talk more on it. Okay. Okay. Thank you so much, and we will just wrap up the session for right now. Nikita, handing over back to you.
Thank you so much, Anuj. It was a wonderful session. So many of them staying back shows that it was really engaging. Thank you so much.
Thank you. Thank you so much.